Hello, this is Mr. Waters, and I'm here to do another example from the homework, page 654, on hyperbolas. And in this one, we're going to analyze the hyperbola described. In that case, or in this case, that means find the center, the transverse axis, the vertices, the foci, the asymptotes, and also we want to graph it as well. So, in this, and then for this problem, we're actually going to be given the equation, which is 4y squared minus x squared is equal to 16. Now, that equation is, of course, not in vertex form. It has to be equal to 1. So we're going to start out by dividing both sides by 16. So we just divide everything by 16. Okay, that's 4 over 16 is going to be 1. So y squared over 4 minus x squared over 16. And then 16 over 16 is 1. So there we go. There's our vertex form. And now we can begin to analyze it. So we can actually, maybe it's a good idea to start, as usual, plotting the points to kind of see what kind of thing we've got. We're going to have to graph it anyway, so there's no reason not to put start to put the information on right in the beginning. And we can see from the equation, number 1, I'll write our answers over here. Number 1, the center, since h is 0 and k is 0, the center is at 0, 0. And now number 2, we can start to plot the information. We can see here that a is equal to 2, because in a hyperbola, the equation, the a value is always first. And we can see that b is equal to 4, because 4 is a squared and b squared is 16. Now, in this hyperbola equation, the y squared is first. That means it has to be a vertically oriented hyperbola. So that means I'm going to go up 2 units to place the vertex, right? And then down 2 units to place the other vertex from the center point, 0, 0. So we might as well just go ahead and label those points. Right now, that's 0, 2, and this is 0, negative 2, and that's the origin 0, 0. Now, based on the fact that that is a vertically oriented hyperbola, the transverse axis has to be going down vertically through the focal points where they'll be, and through the center and through the vertex points. And so you can see here that the transverse axis has to be the y-axis. Okay, the official equation for the y-axis is x is equal to 0, right? So we're going to put down here this is the transverse axis, okay, as x is equal to 0. That's the equation. Now, number 3, we can already see here that the vertices are 0, 2, and 0, negative 2. All right, now we have to figure out the focal points. Well, the focal points we can get from the equation c squared is equal to a squared plus b squared. A squared is 4, b squared is 16. So c squared is equal to 20. So c is equal to plus or minus rad 20. So c is equal to plus or minus, oopsie, it's kind of messy, plus or minus 2 rad 5. Okay? All right, now, which is approximately 4.5, somewhere about halfway between between 4 and 5, square root of 16 and square root of 25. Okay, so that's going to allow us to put where the focal points are. That's, since it's vertically oriented, from the center we're going to go up 1, 2, 3, 4.5 about. and then down 1, 2, 3, 4.5 about right there. So this is going to be 0, 2 rad 5, and 0, negative 2 rad 5. Those are the coordinates for the focal points. So I'll put these over here for number 4 in our results. 0, 2 rad 5, and 0, negative 2 rad 5. Okay, so we're almost done. Now we have to get the asymptotes, and when we have the asymptotes, that'll allow us to complete the graph. Well, if you'll recall, and I'll put this over here, the asymptote equations for a vertically oriented hyperbola are going to be y equal to plus or minus a over bx if the center of the hyperbola is at the origin like ours is. Okay, well, a is equal to 2 and b is equal to 4, so y is going to be equal to plus or minus 2 over 4x, or y equal to plus or minus 1/2 x. Now that just means we'll go over here and we'll go over 2 and up 1. 2 for the b, 1 for the a. Over 2, down 1 for the other asymptote. And now in green, I'm just going to go ahead and sketch the asymptote in. Okay, I'm using a dashed line here because we know that since it's not part of the graph, we're going to dash it so that we don't think that it is part of the graph. It does tell us where the graph is. So under number 5 here are our asymptote equations. Y is equal to plus or minus 1/2 x. So that is our complete analysis answer there. Now we can draw in finish the graph of the hyperbola. Something like this. Something like this. We can see that the graph of the hyperbola goes through the vertex points and curls around the focal points like a parabola does, and the two arms or limbs of the hyperbola snuggle up against the asymptote lines just like the rational functions did. And so there is our graph, and I think that's as much as we need to do for this problem. Thank you so much.